Today we're going to talk about 10.5, which are different angles that are in a circle. We're going to talk about what the different types of angles are and how to find the different measures of them. And we've already talked a little bit about central angles, and then we will add in, and we've already talked about inscribed angles. We'll talk about some tangent chords that are related to inscribed angles, and then chord, and then three different types of angles that have their vertex outside of the circle. And one of the ways that we're going to help talk about these is where the vertex of the angle is located. So the first one we've talked about before is a central angle, where the vertex is at the center of the circle. And when the vertex is at the center of the circle, we've talked about this before, where the angle is equal to the intercepted arc. So in this case, x would be equal to 80 because it is equal to the measure of the arc. Another couple types of angles are related to where the vertex is on the circle. And we've talked about one of these angles before. We've talked about the inscribed angle. And the inscribed angle where the vertex is on the circle, and then the segments rays that construct that are the chords of the circle, and the inscribed angle is equal to half of the intercepted arc. So in this case, x would be equal to 50. Another type of angle where the vertex is on the circle is called a tangent chord angle. So in this case, CB is the tangent segment, and AB is the chord segment. The vertex is still on the circle, so x would be equal to half of the intercepted arc. So in this case, x would be equal to 60 degrees. Another type of angle is where the vertex is inside the circle, but it is not on the center of the circle. So in this case, we have the center is circle O, but the vertex of the angle is off of the center. So in this case, in order to find the measure of the angle here, we have two chords that construct the angle. It really doesn't matter which angle we are talking about, because we can talk about x here or x here because they're vertical angles. So either one of those angles, it has two arcs that the angle intercepts because of the chords. It intercepts this arc of 70 degrees and this arc of 170 degrees. And in order to find the measure of the chord angles, we take half of the sum of the arcs. So we add two arcs and divide by 2. And then last is three separate angles where the vertex is outside of the circle. And it's going over some vocab. We're talking about tangents and secants. The first one is where we have two tangents. So AB is a tangent and CB is a tangent. And when we do this, we're finding half of the difference of the arcs. So we have an arc here of 260. We have an arc here of 100. We'll subtract the two arcs and divide by 2 in order to find angle x. The second one of these with the vertex that is outside of the circle is when we construct an angle using two secant segments. And it again intersects the circle with two arcs, an arc of 80 and an arc of 20. We'll subtract the two arcs and divide by 2. And the last one is where we have a tangent and a secant. And again, it has two arcs, one of 100 and one of 30. We will subtract the two arcs and divide by 2. Let's go over a few examples with these different types of angles. First one here, we have C as the center of the circle. So AB is an arc that goes directly to this central angle, so we can say that AB is 54 degrees. And because BD is the rest of, we know that this is the diameter, so BD is the rest of that half, 126 degrees. Number 2 with C as the center. we can look at GE, which is the arc that corresponds to the central angle. So GE is 75 degrees. And again, EF is the rest of it cut off by the diameter, so cut in circle in half. Subtract it from 180, and we get 105 degrees. Number 3, we have angle 1 is again a central angle with the 2 radii constructing that, so it goes to the arc of 120 degrees. So the angle itself is 120 degrees. And then because this is constructed by 2 radii, we know that this is an isosceles triangle, and it's going to split up the 2 remaining angles, this unmarked angle and angle 2. It will split the 60 degrees remaining, making angle 2 30 degrees. In number 4, we have a few different inscribed angles. For IJ, this arc corresponds to the inscribed angle of 45 degrees, so we know that IJ is 90 degrees. And JK corresponds to the arc of 57 degrees, so we know that it is twice that of 114. And then IK is the remaining part of the circle, so we can subtract 2 arcs that we have from 360, and we get 156 degrees. Go ahead and pause the video and attempt to do 5 through 8 on this page. So for number 5, we have an inscribed angle. So it corresponds to half of that angle, and because this is a diameter, because we have parallel lines, you know that's 43, and we can double it to 86, and then because of the diameter, we can cut the rest of it to be 94. For number 6, we have vertical angles here to give us 83. We can find out the remaining angle to be 40. For angle Q, 70. And then SR is twice that. 7 and 8, we're talking about the angles where the vertex is outside of the circle. So what you should have done to set these up is find out that the angle intercepts the arc, intercepts the circle with 2 arcs. One is 140, and the other one is 40. So x would be equal to 1/2 of 140 minus 40. And so we get that x is 50 degrees. Similarly, in number 8, this is the vertex outside the circle. And because it's a tangent, we know that with the one arc of 140, we can find out that the rest of the arc is 220. So we find out that half of 220 minus 140 is equal to x. We find out that this angle is equal to 40 degrees. Something you'll always notice with the ice cream cone problems, when you have a tangent, this happens to always be true, that the arc and the angle are always equal to 180. They are supplementary to each other. This is only true for the ice cream cone. On this page, we have a few intermixed types of problems, but the first one is one where we have a vertex that is outside of the circle. So in this case, we're given the angle, though, so we have to set 40 equal to half of the 2 arcs, which are 110, and x. we solve this, I will multiply by 2 to both sides here with a half. And I find out that that arc that I'm missing is 30 degrees. For number 10, we use some inscribed angle stuff first. So because this angle is 20 degrees, I can find out that this arc is 40 degrees. With this inscribed angle of 80, I can find out that its corresponding arc is 160 degrees. I now have enough information to do the angle x that I was looking for, where it's a vertex that is outside of the circle. I can set it equal to 1/2 of 160 minus 40. And get that x is 60 degrees. For number 11, we need to first look at, well, we have the vertex that is outside the circle, so we have a secant angle, and we need to find this arc and this arc. In order to do that first, I need to look at the inscribed angles. So I have an angle here of 28, which tells me that this arc is 56. In order to do this arc, I need to look at the inscribed angle here. But I first can look at the triangle that I have, knowing that this angle is 120, and I have 28. We have 32 degrees there. So because it's an inscribed angle, the arc is 64. So half of 64 minus 56 leaves me with 4. And what we talked about previously here, because this is an ice cream cone, I can just open the supplementary and set x equal to 130. A couple more problems. The first two are dealing with chord types of angles primarily here. So because we're looking at x here, the vertex is inside the circle but not on the center of the circle. So I will look at the two arcs that intersect, which are 15 and 47. Not drawn to scale clearly, but half of 47 and 15 to solve for x. And I get 31 degrees for x. (14). In this case, I'm solving for one of the arcs, so I'm looking for that arc of x. I have the other arc that it intersects opposite of it, which is 100. So what I really need are one of these two angles, which are 105 degrees. So then I can set 105 equal to 1/2 of 100 plus x. And find that x is 110 degrees. And in order to do number 15, I need to first look at, I have two different circles going on here. On the inside circle here, I have an inscribed angle at the vertex of x. And that inscribed angle corresponds to the arc of 112 degrees, which tells me that that arc is 56. If I'm now looking at the arc of AB, in the bigger circle, this is the vertex of the angle on the inside, but it's not the center of the circle. And that corresponds with the arc of 87 because of the chord. So I can set 56 equal to 1/2 of 87 plus the arc of AB. And I get that, after I solve that, the arc of AB is equal to 25 degrees. And that concludes the section on angles and arcs for 10.5.